Improving our I/O project. With this new knowledge about iterators, we can improve the I/O project from Chapter 12 by using iterators to make places in the code clearer and more concise. Let's look at how iterators can improve our implementation of the config new function and the search function. Removing a clone using an iterator. In listing 12.6, we added code that took a slice of string values and created an instance of the config struct by indexing into the slice and cloning the values, allowing the config struct to own those values. In listing 13.24, we reproduced the implementation of the config new function as it was in listing 12.23. Implementation for config, public function new takes args of type reference to a slice of string values, returns result, config, and reference to a static string. If args.len is less than 3, return not enough arguments. Let query equal args1.clone. Let file name equal args2.clone. Let case sensitive equal env var case sensitive dot is Okay, config query file name case sensitive. At the time, we said not to worry about the inefficient clone calls because we would remove them in the future. Well, that time is now. We needed clone here because we have a slice with string elements in the parameter args, but the new function doesn't own args. To return ownership of a config instance, we had to clone the values from the query and file name fields of config so the config instance can own its values. With our new knowledge about iterators, we can change the new function to take ownership of an iterator as its argument instead of borrowing a slice. We'll use the iterator functionality instead of the code that checks the length of the slice and indexes into specific locations. This will clarify what the config new function is doing because the iterator will access the values. Once config new takes ownership of the iterator and stops using indexing operations that borrow, we can move the string values from the iterator into config rather than calling clone and making a new allocation. Using the returned iterator directly. Open your I/O project's main file, which would look like this. Function main, let args of type vec of string equal env args.collect. Let config equal struct config new reference to args dot unwrap or else close on println problem parsing arguments process exit 1. We'll change the start of the main function that we had in listing 12.24 to the code in listing 13.25. This won't compile until we update config new as well. Let function main, let config equal config new env args dot unwrap or else close println problem parsing arguments process exit 1. The env args function returns an iterator. Rather than collecting the iterator values into a vector and then passing a slice to config new, now we're passing ownership of the iterator returned from env args to config new directly. Next, we need to update the definition of config new. In your I/O project's lib file, let's change the signature of config new to look like listing 13.26. This still won't compile because we need to update the function body. Impl config pub function new takes mute args, which is a standard env args, and returns result te, I suppose, config, and a reference to static string. The standard library documentation for the env args function shows that the type of the iterator it returns is standard env args. We've updated the signature of the config new function, so the parameter args has the type standard env args instead of reference to a slice of string values. Because we're taking ownership of args and will be mutating args by iterating over it, we can add the mute keyword into the specification of the args parameter to make it mutable, using iterator trait methods instead of indexing. Next, we'll fix the body of config new. The standard library documentation also mentions that standard env args implements the iterator trait, so we know we can call the next method on it. Listing 1327 updates the code from listing 1223 to use the next method. It's in lib impl config. Public function new takes mute args of type standard env args, returns a result of types config or reference to static string. args.next. Let query equal match args.next. Some arg return arg. None return didn't get a query string. Let file name equal match args.next. Some arg return arg. None return didn't get a file name. Let case sensitive equal env var case sensitive dot is Okay, a config query file name case sensitive. Remember that the first value in the return value of env args is the name of the program. We want to ignore that and get to the next value. So first we call next and do nothing with the return value. Second, we'll call next to get the value we want to put in the query field of config. If next returns a sum, we use a match to extract the value. If it returns none, it means not enough arguments were given, and we return early with an value. We do the same thing for the file name value. Making code clearer with iterator adapters. We can also take advantage of iterators in the search function in our I/O project, which is reproduced here in listing 1328, as it was in listing 1219. It's in lib public function search over lifetime A, take query of type reference to stir, and contents of type lifetime A reference to stir, return vec of lifetime A reference to stir. Let mute results equal vec new for line and content.lines if line dot contains query results push line results. We can write this code in a more concise way using iterator adapter methods. Doing so also lets us avoid having a mutable intermediate results vector. The functional programming style prefers to minimize the amount of mutable state to make code clearer. Removing the mutable state might enable a future enhancement to make searching happen in parallel, because we wouldn't have to manage concurrent access to the results vector. Listing 1329 shows this change. Public function search lifetime A takes query reference to string and contents reference to lifetime A. I said reference to string before, it was reference to stir. Slice, yes. Contents reference to lifetime A, stir. Return a vector reference to lifetime A stir. Contents.lines, filter, close on line, line.contains, query, collect. Using iterator adapter methods in the implementation of the search function. Recall that the purpose of the search function is to return all lines and contents that contain the query. Similar to the filter example in listing 1319, this code uses the filter adapter to keep only the lines that line.contains query returns true for. We then collect the matching lines into another vector with collect. Much simpler. Feel free to make the same change to use iterator methods in the search case insensitive function as well. The next logical question is which style you should choose in your own code and why. The original implementation in listing 1328 or the version using iterators in listing 1329. Most Rust programmers prefer to use the iterator style. It's a bit tougher to get the hang of at first, but once you get a feel for the various iterator adapters and what they do, iterators can be easier to understand. Instead of fiddling with the various bits of looping and building new vectors, the code focuses on the high-level objective of the loop. This abstracts away some of the commonplace code, so it's easier to see the concepts that are unique to this code, such as the filtering condition each element in the iterator must pass. But are the two implementations truly equivalent? The intuitive assumption might be that the more low-level loop will be faster. Let's talk about performance.